Greenhouse effect and IR radiation. What is the greenhouse effect? Energy from the sun covers the entire electromagnetic spectrum. However, the majority of this energy is concentrated in the UV, visible, and IR region as seen in the yellow line on this picture. The Earth's troposphere contains the majority of the greenhouse gases. Carbon dioxide, followed by methane, nitrous oxide, and water, are the most common greenhouse gases found in the troposphere. These gases absorb energy from the sun that is in the IR region. Energy in the visible region can pass through and make it to Earth's surface. As the greenhouse gases absorb IR energy, they begin to vibrate and rotate faster, which creates heat by friction. This friction is what keeps our planet warm enough for life. However, just absorbing IR energy from the sun wouldn't be enough to defrost our planet. Additional energy needs to be converted to heat when the visible light reaches the surface. 51% of the energy in the visible region is converted to heat when this energy hits the surface. About 4% of this energy gets re-emitted back out towards the atmosphere as IR radiation to speed up the movement of greenhouse gases even more. What makes a molecule IR active? A molecule is IR active if it has a permanent dipole or a dipole moment. Water has a permanent dipole because it exhibits polarity with all bonds at equilibrium. The overall dipole moment of the molecule is shown. A molecule can still be IR active even if it does not have a permanent dipole. If the molecule can have a position in which the overall polarity of the molecule is non-zero, then it can still be IR active. Carbon dioxide has a dipole moment. The structure of carbon dioxide in equilibrium, bending mode, symmetric stretching, and asymmetric stretching is shown. During equilibrium and symmetric stretching, the carbon to oxygen polar bonds of carbon dioxide cancel out, making the molecule not IR active in these states. When carbon dioxide is in bending mode or asymmetric stretching, the carbon to oxygen polar bonds no longer cancel out, and the molecule is considered to be IR active. The structure and vibration spectra of the greenhouse gases are shown. Water and nitrous oxide both have permanent dipoles. Carbon dioxide and methane have dipole moments. A water molecule has two planes of symmetry as shown, so it falls under the C2V point group. Group theory and the greenhouse effect. Group theory is used to illustrate how the symmetry of a molecule is related to its physical properties. Group theory is centered about a set of numbers associated with the symmetry of a molecule. This is called a point group. We know that water belongs to the C2V point group. Looking at this point group, we see that the A1, B1, and B2 vibrational modes are IR active because the X, Y, and Z indicate linear bending and stretching that have dipole moments. Some dipole moment equations. The equation for the dipole moment of a molecule is shown, where mu is the magnitude of the dipole moment, alpha is the polarization constant, and epsilon is the electric field. The second equation shows that the change of the magnitude of the dipole moment has to be non-zero to be IR active.